Binomial Expansions Part 3. You should watch Part 2 before continuing with this video. The binomial expansion for root 1 minus 2x is given here. The first four terms are given, and the expansion is only valid for x to be between minus a half and a half. Now we're going to use the value of x as 0.01 to estimate the value of root 2. Now to estimate root 2, what you can't do is just use your calculator and then do this. You have to use the binomial expansion. So if I substitute in x equals 0.01 into here, and then I put the same value of x into my expanded terms, like this, and 0.98 is just the simplified version of all of this. What I get here will be my estimate. It will lead to my estimate, and my value of x that I'm using is in the interval. So the right hand side here gives me this, and 0.98 can be written as 98 over 100, because you might be wondering, where does the root 2 come into all of this? You don't see a root 2 anywhere at the moment. So this is exactly the same as that 0.98, and root 98 can be written as root 49 times 2, and you can see the root 2 right there. So we can split this into root 49 times root 2, and root 49 is 7, root 100 is 10. So now we need to rearrange to get root 2 by itself. So if we multiply by 10 and divide by 7, we have an estimate for root 2. The challenging part in this wasn't the 0.01 and substituting it in. That was easy. That was the simple part. The challenging part is how to pull out root 2 from this 0.98 to know that you can write this as a fraction, and then working with surds you can come up with a root 2 somehow, and then isolate that root 2. Now you can see that the value from the calculator, so we'll call this one the exact value, even though it's irrational and it goes on forever, the exact value and the estimated value here, they're quite similar, but they're not the same. If you look at the last few digits there, they do differ. So what's the percentage error in our estimation? So we're going to work that out next. Okay, so the percentage error is the positive difference between our two values, the approximate and the exact one, divided by the exact value times 100. So to get a positive difference, you can either do the exact minus the approximate value, or the estimated one, or you can do the approximate minus the exact. Yeah, it's basically the largest one minus the smallest one here in the numerator. You divide that by the exact value, which is what your calculator gave you for root 2, and you multiply by 100, so you get this. A very, very small difference, and we're looking for a positive value here, which is why the difference there was calculated as the largest minus the smallest, the largest value minus the smallest value out of these two. In this example, we're looking for a specific term, the x squared term. We're not estimating anything here, it's just the x squared term we're after. So we need to rewrite this first, like this, and the 2 plus x was in the numerator, there it is, and you've got 1 over, and then you've got root 1 plus 5x. Okay, so changing from surd form to index form, and then when I bring all of this out, I have to change the sign on the power there, so it becomes minus a half when you bring this out, and the 2 plus x needs to be in brackets like this. So the 1 plus 5x to the power of minus a half needs an expansion. We need to do a binomial expansion first. I've done that already. I've got the first few terms here. Remember, we're looking for the x squared term, so there's no point continuing to expand beyond x squared. You'll get x to the power of 3, x to the power of 4, and so on. We're not interested in those. Now we need to multiply these terms out, and the grid method is recommended. So you've got your 2 plus x down here, that's 2 plus x, and you've got the other terms there, the red ones along the top, and we're only expanding for x squared. So something like this, minus 5 over 2x there multiplied by 2. There's no point working this one out. It's not going to give you an x squared term. Likewise, the term that would go here would be this times this. So it's just like a multiplication grid. You just multiply them together, but that would give you an x cubed term. We don't want that one either. So the only two x squared terms you get are 2 times that term and x times this term. And now we have to add these together, and we get 65 over 4 x squared. Now the question did say just find the term. If it said find the coefficient of the x squared term, then your final answer would have just been 65 over 4. In this example, one of the terms in the expansion of 1 plus kx to the power of minus 4 is given, and it's the linear term. And the linear term, the x term, is usually the second term in the expansion, so we don't need to go anywhere past the second term in the expansion. Okay, so first term, second term, and we know that this is this. They're equal. Okay, so simplified, so I've got my minus 4kx term, which was this, equal to 20x. We can cross out x from each side, and then k is equal to minus 5. For practice, do these questions.